All right, welcome back to good choices, medium-sized choices, whatever. But we're gonna read this book, "Automate Your Network" by John Capobianco. We're gonna keep reading that. So, what we got to do is build out the network first, because as I've said many times, this depends on a pre-existing state of the network. And really, that's kind of unfortunate, because the pre-existing of the state of the network is kind of the thing that would be great to automate. But the fact remains that we need to set up the network to that pre-existing state before we can get further in the book. So let's do that. The other thing I want to say is there's a channel called Jeremiah Wolf that everyone should stop watching me and go. It's more for so this is a great channel, but it's more for people kind of who's had like a lot of experience in IT, has been through some ups and downs. And so this is a great channel for that, to kind of, it's like an insider channel, I would call it. But and then there's kind of some advice on this channel for like who to follow and who to respect, which is like really important as well. And you can make your own decisions about that. I certainly have, but I think this is a good source you can use to help yourself make a good decision. So one thing I do need to go out on a limb and say, though, is that this channel's great. Like, yes, there are YouTube things on it. I think YouTube and social media is not great. So like you have things like an emphasis on hacking. You have things like that are kind of designed more for entertainment than for education. But all in all, I think this channel is certainly inspired me, and certainly is a great resource. So the things I recommend, I think like a lot of the times you can skip like a lot of the channel. The things I recommend looking at is the inspiration. So if you go to playlists, there should be one for inspiration where he's just like, because sometimes it's just good to have somebody definitively say like, yeah, luck can be a part of your career, but kind of your sense of agency isn't a total illusion. So you can always do better in some way. Like sometimes that's good to hear. So I used to have these. Oh yeah, here we go. So life motivation. It looks like he's only got 7 of these videos. I'd like to see more of these, but yeah. So there's like good questions. We'll ask like, what's your focus? What are you doing right now? So I definitely recommend checking out this content. I think this is great content, and David Bumble is the real deal. CCIE emeritus. You buy a course or get a course through your work, it's probably going to be taught by David Bumble. He's all over the online teaching space. This is just one of the areas he's at when it comes to teaching online. So the other thing I definitely recommend, and these playlists are kind of all over the place. I'd like to see it more like this is good, life and motivation to keep you studying. But I'd like to see a playlist for interviews, because that's the other thing I definitely recommend. There's people. It's about people. Like fundamentally, you might think technology is all about the the bits and the hardware and all that, but really in the end it's about people. You wouldn't need to make a computer if there wasn't a need for a person to use it. So getting to know some of the really important people in the space, I think is absolutely invaluable for your career, absolutely important. So that's the other thing I would recommend, just skipping right to. Get to know some of these people. Who is this guy here, Ivan? Yeah, let's get to know who he is. So he's another CCIE emeritus. Any CCIE emeritus or current, listen to them, please. So I'm actually gonna follow him. Yeah, so that's the other thing I would recommend is skip right to the interviews with people that matter to you. If you're in network engineering, listen to get this guy. But if security, you're not really in that, skip those interviews. Stick to these. If you want to get into security, yeah, watch all the security interviews. So just stick to what matters and what is relevant to you. And definitely check out this channel. I was actually watching this interview with somebody I can really relate to, somebody who was, I switched careers to this in 2013 with like no prior training. So like my career, even though I'm approaching 40 very soon, is still less than 10 years old. So like, this is somebody who's kind of in my boat, where like they feel like, oh, I'm in this space of where like I've just got so much to catch up on, because I should have been doing what I'm doing now 30 years ago. Like I get that same feeling from this guy. So like, what was his answer? His answer was to grind and work towards CCIE JNCIE certifications. And like, that's not a bad answer. That's kind of what I'm trying to do too, is just rack up some certifications, because I do believe in certifications. So yeah, that's what I wanted to say about that. I also want to make a specific comment about the idea of being replaced, about having your jobs no longer be relevant and be replaced. So I think that is a real concern. And I think the best way to handle that is to get ahead of the waves, like ride the waves. But at the same time, I think one thing I would say is that if there's a need to replace your job with some sort of technology or automation, that means that your job must be done faster and it must scale up. So like that doesn't mean that your job is less valuable. That means your job is so valuable that people are working really hard to optimize it. So it's not like once people figure out how to replace your job, that your job's going to go away. It's that your job is going to get hyper optimized and streamlined, so that more sophisticated, larger scale projects that require some or all of your job skills can be deployed. And you actually might find that space grows with job opportunities, because now we're no longer working on these small jobs that we have to depend so much on a very highly skilled human for. Now we can scale up these jobs and these ambitions, these networks. I mean, think about it. Like if we have a innovation where like, the subterranean cables, I think what they're called, so ocean internet cables. Let's say we have some advancement where we just make a way better ocean cable, and we the whole process of doing the ocean cable is going to be automated, and as such, with all those advancements, we can replace all our ocean cables. Is that going to be a situation where there's fewer jobs or where there's more jobs? I will tell you right now, that will be a situation where there are more jobs created. So I don't think that's really that big of a concern that, oh, AI is going to replace my job. But I do think it's a good investment to kind of stay ahead of these waves. And I think staying in the space makes a lot of sense. So like even if you're just doing nothing and kind of doubling down on your current skill set, with the concern that it'll be irrelevant, it's like, well, if there's a need to make your job irrelevant, that's because they want to hyper optimize it so that they can scale it up. So what that actually means is that your job is going to become more relevant because they're going to be doing bigger jobs that require the skills you have. So, I wouldn't take that as, oh no, I must get out of IT entirely because it's just going to go bankrupt. I would take it as IT is going to become more and more and more valuable and sophisticated, and I better make sure that I belong in this space, whether that means really becoming an expert in what you do, even though it might be the kind of thing that is first to get automated away, or to get ahead of the trends and to ride the waves, which I do think is great advice. I think that an associate beginner level cert can sometimes be more valuable than a expert level cert, depending on the subject matter that it is in. I honestly believe that, and I could be wrong about that. I hope to be proven wrong about that because I did throw my hat in the ring for an expert level cert and kind of came out battered and bruised. But only time will tell. All right, so that's what I want to say about that. I just think that's really important. And if you're watching me, I just got to be honest. I am not David Bumble. I'm not even Jeremiah Wolf. There are better people out there for you to watch, and I'm going to be honest and transparent about that. I'm not even Gina. I forget what her name is. You can just type in cloud engineer. Oh no, yeah, I'm not even. Oh no, it's not Gina. It's Pina. That's probably where I got Gina from. I'm not Gwyneth. She's working for Microsoft. Obviously a very thriving. It's somebody who's able to do social media on another person's dollar. Social media is a great. You're working from home, kind of making your own schedule in a way. Like, I just want to be transparent about who I am, and what I can bring. So, see, like, I do not drive a car like this. Okay, but sometimes these channels, I must say, if you learn from somebody at the top, sometimes they kind of forget what you're dealing with. So you can stick with me, and some of the things I actually genuinely struggle with and I'm trying to figure out might be a lot more relatable. All right, so sorry about that. That's kind of a rant. Less than 15 minutes, though, so I'm good. So we're going to continue building out this host.ini file. We'll refresh the login session. Okay, and sign in with Google. Okay, so now we're going to continue doing this. So let's feed it the second. Okay, so section 2. And we're going to call it, yep. Section 2 will be core. And I'll start up the lab. we could feed it probably all three at once. Section 3 is internet. All right, and then we don't need to include this because it's not going to be automated. It's just the wire from the ISP that we're purchasing, so it doesn't require any automation. The automation ends at this port here. All right, next part is the WAN. All right, and then we got one more section, which is floor 1. So we've got 5 sections. All right, now this one's kind of tricky because I'm not sure. I think that the network technically ends like here, and then these are just PCs plugged into the network. But we do need to do some basic things like make sure DHCP is set up on these, make sure that DNS resolves quickly. But, you know, again, those are all going to be things that are done on the network. If we do need to do something like 802.1x to make sure that these are secure connections and not just anything can plug into our devices, then we will need to add something to these. But for now, let's not include those in our communication with the AI.
Based on the additional sections and devices you provided, we can extend the hosts any file accordingly. For these devices, we will maintain a simple and descriptive naming convention, which can be helpful in identifying the role and function of each device in your network. Here's how you can organize the hosts any file with the additional sections. Note: : I have corrected the naming of the FLOR02 devices under the FLOR01 section to be under a separate FLOR02 section, assuming this was a typographical error.
Oh, really? Why?
Group names are in uppercase for consistency as per your preference, but you can change it to lowercase if you prefer.
Why?
This structure clearly divides the different sections of your network and makes it easier to manage and apply configurations to specific sections or devices using Ansible. If you have any specific details or additional information to include, please let me know, and I can adjust the inventory file accordingly.
Why did you split up floor 1 into floor and 02?
I apologize
Wait.
for any misunderstanding. It appears there might have been a miscommunication or typo in the information you provided. You listed the following under Section 5. Floor 01.
Oh.
Here, there are devices listed with both FLOR01 and FLOR02 prefixes. Assuming that devices with FLOR01 prefixes belong to the first floor and devices with FLOR02 prefixes belong to the second floor, I created 2 separate groups to accurately represent the different floors. However, if all these devices are meant to be on the first floor and FLOR02 and the names was a typo, then they should all be listed under the FLOR01 group, like this. Please confirm whether the distinction between FLOR01 and FLOR02 was intentional or a typo, so I can provide you with the most accurate inventory file.
Is that what I have in my lab? No, I have it correct in my lab. Yeah.
No. Problem. Thanks for clarifying that. Here's the corrected hosts. Any file with the accurate naming for the FLOR01 section. Now. All the devices in section 5 are correctly grouped under FLOR01 with the appropriate naming. If you have any more sections or adjustments, feel free to let me know.
Okay, so yeah, that looks good for me. So you might think like, oh, this is pretty easy. Why did I need to ask the AI for that? So I didn't, but I want to have a discussion with it. So that's why. So tell me more about Ansible host.ini files, the best conventions. Well, first let me so .ini file complete. I'll stage the changes for that. Okay, and let's look at our branch. So our branch is the campus fax branch. I think I want to kind of change up my workflow here and get that work added to the system in a different and better way. Okay, so let's go to the Azure server. Here it is, and we'll go to boards and work items. So now we've got this work item, campus fax. Let's make a new work item, and let's do an epic because those can go on the Kanban board. And then we're gonna assign it to me. It's in the to do for now, but the title is gonna be network. So we're gonna call it prereq network health. Okay, we're gonna say network health, building out the required network health for automation. And then let's add something to the discussion. Let's add a description from our yeah. So this is just an example of some of the things we'll need to, in our okay. So we'll put that okay. This is just an example of some of the things we'll need. We'll need probably more things than this, but it's better than nothing. All right, that looks good to me. Oh man. Yikes. Okay, so now we can save it. And now we've got an epic, which I'm not really used to seeing, but it's on the board now, which I love. I just like it, seeing it this really easy way. So now we can create a new item, and we can do child tasks to it. So so let's think about the next task that we need to do. So we definitely needed to create that INI file. So we're done with that. The next thing we need to do is we need to we need to architect the entire network. Yeah. So this is a directional link. So yeah, so we need to architect the whole network. Uh, so we definitely need to do that. Um, we also I wish there was an easier way to see this. So like yeah, so we build out the prereq. So one child thing we need to do is architect the whole network. So let's go to that. Let's add a link to this one. We'll create a new item, and then this is going to be a predecessor before we architect the network. We'll break it out into this here. So application layer configs. So set up application layer configs, and we'll break it out that way. Yep. Okay, and this is a predecessor. Okay, so we can save that. So now we've got now from here we can yeah, so after we're finished this, we can close out the entire network. Okay, so now we can create a new item and then just build out all the predecessors, which will be all of the different layers of the OSI model. And then we can even add this in there. Yeah, I like that. Okay, yeah, this is good. This is good. So yep, so let's add the description in here. Set up presentation layer configs. So if we click on this, we've got the child, so it's a predecessor, so architect the whole network. Now we can see it didn't save any of my things that I told it to save, which is a problem. But let's add this back to it, and then try hitting the save button. I have a feeling that won't work because it. Okay, there we go. It just seemed a bit too simple to me. So this is task 6. So the precursor task will be so the predecessor will be task 7, which is set up application layer configs. So we'll just do it all like this. All right, and then we need a predecessor to this. Yeah, so here's the application layer configs. This has a predecessor as well, setting up the presentation configs. There we go, and see what I'm doing here. So I think this will make sense. Okay, I'd like to do a save without closing somehow, but okay, so we got to go back to it because it's a predecessor. Now we only have a successor, not a predecessor. Let's add a predecessor. And we're just going back all the layers. But see how stupid this is? It's like I have to do all of this manually. And like these are legitimate like predecessors and successors because I can't do I can't set up DHCP until I can't set up like some of these until I've set up other things. Okay, so I guess if I do it as a comment there, it doesn't really work. So now let's see if I can save without closing. I can. Okay, and let's add a predecessor to this, which will be the transport layer. Okay, add a link. Network layer. All right, and then the data link error or layer. Okay, and then before that, so physical layer, layer 1. This one we've already got done, so I can put this in the done. Okay, so now we've got all these tickets here that have predecessors and successors, except for this one. So this one's assigned to me. Let's move this to done because we've got them all connected. Okay, and now here's the next one, the data link layer. This is the one we've got to do. So this will be. Let me go to the successor for this one. Yeah, because I think I got that wrong. Okay, save that. Okay, and now we can close all these. These are just a part of the epic, so we can do the yeah. Okay, so now let's mark this one as doing, which will be the so the physical layer we've got it as done, so it doesn't even show up in here. So now the data link layer is next. Change that to doing. All right, and then let's work on getting this data link layer set up. So we need to configure Ethernet settings. We need to set up VLANs, and then we need to implement STP. Okay, so okay. Okay, great. Okay, great. Thank you. Now that my network is defined in my hosts.ini file, help me bring my network to a prerequisite state of health in which I can implement Ansible automation and a modern network development life cycle that includes tools like the Microsoft Azure DevOps server. Help me understand what and why. Help me understand the what and why when it comes to the pre-existing requirements. Yes.
Bridge. Bringing your network to a prerequisite state of health for implementing Ansible automation and integrating with modern development lifecycle tools like Microsoft Azure DevOps requires several considerations. Here are the key steps and the rationale behind them. 1. Enable SSH access. What? Ensure all network devices have SSH enabled and are accessible from the Ansible control node. Why? Ansible uses SSH for connecting to and managing Unix-based systems. Secure, consistent access is essential for automation. 2. Configure authentication. What? Set up consistent authentication mechanisms like key-based authentication or centralized AAA authentication, authorization, accounting across devices. Why? Secure and streamlined authentication is crucial for automation scripts to log in and perform tasks on the devices. 3. Standardized configurations. What? Standardized base configurations across devices, including hostname, logging, SNMP, NTP, etc. Why? Consistent configurations reduce variability, making automation scripts more predictable and reducing the chance of errors. 4. Upgrade firmware, software. What? Ensure all devices are running supported and up-to-date firmware, software versions. Why? Older firmware, software versions may lack features or have bugs, impacting automation capabilities and stability. 5. Network documentation. What? Maintain accurate network documentation, including IP address assignments, VLANs, routing, etc. Why? Clear documentation helps in creating accurate Ansible inventory files and playbooks. 6. Enable API access. What? If your devices support it, enable and configure API access, e.g. REST API. Why? APIs provide a structured way to interact with devices and are essential for integrating with tools like Azure DevOps. 7. Set up version control. What? Store your Ansible playbooks, roles, and inventory files in a version control system like Git. Why? Version control is fundamental for tracking changes, collaboration, and integrating with CD pipelines in Azure DevOps. 8. Implement CD. What? Set up continuous integration, continuous deployment, CD pipelines in Azure DevOps for testing and deploying configurations. Why? CD pipelines automate the testing and deployment of network configurations, ensuring reliability and quick rollback in case of issues. 9. Test environments. What? Create representative test environments to validate Ansible playbooks and configurations. Why? Testing in a non-production environment is crucial to catch issues before deployment, reducing the risk of network outages. 10. Monitoring and logging. 11. Backup configurations. 12. Skill set and training. By following these steps and understanding the rationale behind them, you can ensure your network is in a healthy state, ready for the implementation of Ansible automation and integration with tools like Azure DevOps.
Okay, so this is pretty good. It kind of blows my tickets out of the water because I should have tickets for each of these. So we can leave the skill set and training out because it's just me. But all these we need to have. Okay, perfect. Can you please fix number 10 and number 11 so that it's not in that markdown box and it's in the same format as number 9, 8, 7, and so on? You can leave out number 12.
Certainly. Exclamation mark. Here are items 10 and 11 revised in the same format as the earlier points. 10. Monitoring and logging what? Implement comprehensive monitoring and logging across your network. Why? Monitoring and logging are essential for troubleshooting, identifying issues proactively, and auditing changes made by automation. 11. Backup configurations. By following these steps and considerations, you can set a solid foundation for implementing Ansible automation and incorporating modern network development lifecycle tools.
Can you try it again for number 11? You got number 10 right, but not number 11. It's still in the markdown.
Apologies for the oversight. Here's number 11 revised math format. 11. Backup configurations. What? Regularly backup device configurations. Why? Backups are crucial for quick recovery in case of misconfigurations or failures during automation. I hope this aligns with your expectations.
Okay, yeah, that's good. Alright, I got pause. I'll be right back. Alright, I'm back. Had a bit of a extended break there. If I sound kind of like out of breath and like, I don't know, like not super vibrant, it's because I'm out of breath and not super vibrant. I just kind of need to make some lifestyle changes and lose some weight. All right, so let's keep going with this. So we have the so we have our list of tasks here. Let's change the tasks we made in here. So the epic is good. Building out the prereq network health for automation, which sucks that we can't automate that. But I like this. It's just like the this child here is probably fine, but it's like it's just I don't like these. So let's delete all these tasks, even though we just did that, and remake them, because I just don't feel like they're really appropriate, and it's not that big of a deal to delete them all. And especially this one, architect the entire network. That's just silly. So let's even get rid of the campus facts task, because we're just not there yet. So let's delete all of these into the recycling bin. What? I don't understand why it's so difficult to do things that would be pretty easy. What? How do I delete all of these? Oh, here we go. So I can right click and I can do delete. So so let's delete the selected work items. There we go. And now all we've got left is this epic, which is good because we can list the epic on the board. So let's do that same process where we make basically like a connected string of tasks with each depending on the other. But let's do that with this here. So and we'll do it working backwards as well. We're gonna have the backup configurations as a as a predecessor of the precursor logging and monitoring, and so let's do that. So we're gonna create a new item, and then this is a predecessor to building out the prereq network. So it's, well, let's make it a child of it. Yeah, so it's a child of this, and then it's a task. It's not a predecessor. It's a child task, subtask that falls under this epic. So so it's a, there we go, a child, and then it's a task. We could also make it an issue, but we certainly don't want to make it a whole nother epic. I mean, we could do that and it would show up on the board, but let's just keep this one epic on the board. Okay, and now that the title, that's the easy part. Backup configurations. We'll have the number in there too, so it's like easy to see. And then create that. Okay, and then we'll add the description. There we go. Let's make sure it's assigned to me. Hit a save on that. Okay, and then there we go. And now we can add predecessors to this. So we're going to make a new item. And instead of being a child of this one, it's going to be a predecessor. There, see how this works? This is actually like pretty helpful. Like sometimes like if you have used this sort of thing in the wild, you might think like, oh, this is just annoying and gets in the way. But if you really, I think, take the time to nail it, I think it can actually be a help instead of a hindrance. So there we go. So we're saving that. So yeah, it's like really clear now. It's really helpful. So we're gonna make a new item here. Another, and we're just gonna build out all our predecessors. And this might take me a little bit of time, but I'll do it all on camera. We're only at 45 minutes. That's like nothing. Easily go twice as long. Okay, so now we're at number 8. And I like the numbers in there because it makes it very clear. There's probably a faster way to do this, but you can like script this or automate this. But sometimes you spend too much time. You spend hours trying to save a few seconds of work. It's like just spend just spend those few seconds. It's time well spent. Okay, so yeah, so we got quite a few of these still. This is only number 7. Oops, I do not need this to be open. But it won't close, which is making it difficult. Okay, so let me think of what I was doing. Okay, I was having this. So there we go. We did a cut. All right, then we're gonna add a link again. Okay, we're down to 5. Making progress. And some of these are, just going to be deleted or closed out without really having to do anything. It's just a general guidance. It's better than nothing, in my opinion. I mean, this is just a big project, so we got to treat it as such. I've been wanting to do this for years and years, and it's like it's just been too big of a project. So like without the AI, this is like impossible. Like you would require so much. It's not impossible, but like you would have to be like well at or well beyond the CCIE level. And to be honest, I might be near that level. I mean, I just took my JNCIE, didn't pass, but it's like scoring a bucket from the bench of an NBA team. It's like just taking it and getting 1 point on it is a big deal, in my opinion. Even if it takes 1,000 points to pass, like, you're not LeBron James, but you're Brian Scalabrine, and Brian Scalabrine can beat a lot of people in basketball. It's just LeBron James is unimaginably good at basketball. Oh, so it looks like we got a problem here. Um, oh, I don't know. Okay, there we go. I just misclicked there. So, oh, good news for me. One more to go. Oh, what happy days. Okay, perfect. Look at that. That's wonderful. So, we're saving it. There we go. And now we've got all our tasks on 1, 2, 3, 4, 5. And we've got the description save 6, 7, 8, 9, 10, and 11. We don't need the 12th one to train people because it's just me. So these are all children of my epic, and then um, their predecessor tasks. So we can open my epic, and we can see the child here. We probably should have done it in the reverse order, because then we would have it. Yeah, we should have done it in the first order. You know what? I think I might do that, just because I just want to demo how this can be a help as opposed to a hindrance, because I'm sure a lot of people, it's like conscious incompetence or like conscious competence, where it's like people have used this before and it's just been like, oh, what a nightmare. This is horrible. It's not making my job any better. So like I want to do this in a way where it's like, oh yeah, this not only makes sense to use, I wouldn't really be able to finish my project without it, because it would just be so disorganized. So I want to make everything perfect. Let's see if I could just do something, if I could just change up the order. So now this is a successor. Um, so I guess I could just delete. You know what? Let's do that. Let's just remove all the links, because this is still what we want. There we go. We'll just remove all the links. Um, yeah, and save, and then we can use this here to go down. So and then we'll add back the links that make sense. So look at that. You can even do it in a way that's not that painful. We just got to make sure not to. Well, we can even remove the links from the epic, because we're gonna need to add the links back. So look at that. It's really not much complaining is. There's not a lot of room to complain in a valid way here. Really not that hard. And you gotta understand too, like, I'm building out a full, like, this is a pretty complicated thing I'm doing. So like, if I can do it for this project where I'm turning up a greenfield network from day 0, then just like adding another switch to a brownfield should be not much to complain about. Okay, so now we can add a link here. So let's add a link for an existing item, and then it's going to be a child. All right, and then the item we're going to do is labeled number 1. All right, so now we can click on the number 1, and here we go. You know exactly what I'm going to be doing. So this is no longer a child. This is a successor. And number 2. Yep. And then we just do that all the way through. Yep. Looks good to me. And so now the predecessor is number 1. So we're going to add the successor for a existing item. There we go. Which will be number 3. There we go. So now we've got the predecessor, which is number 1, and the successor, which is number 3. See how cool this is? Okay, so same thing. Now we're at number 4, so the successor is going to be we're at number 3, so the successor is going to be number 4. And we got to save it. Okay, we're at number 4. Successor will be number 5. Alright, successor will be number 6. And number 7. Oh, so it looks like we've got a bit of an issue here. So we've got 2 successors, successor number 6 and successor number 7. This is task number 5, so it's a good thing we got these numbers there. Predecessor, yep, 4 makes sense, but 7 does not make sense to have as a direct successor to number 5. All right, so the predecessor is 5, so this is the one where 7 makes sense. Okay, so we've only got 11 to go, so hopefully we'll be done with this pretty soon. Number 8 is next. All right, and then number 9. And number 10. All right, and then the final item, number 11. Oh, and we've got to move on to the next ticket. There we go. And now add the final item. Okay, so now we can save it, and then we'll close all these, make sure there wasn't one that accidentally didn't get saved. There we go. And now see how easy this is now. We can go to, oh, this one didn't get saved, so we're going to save it. There we go. And now see how easy this is. We go to the boards. We see what we're doing is we're working on this epic to build out the pre-required network health for automation. So we can click on that. We can see the child is the first task is to enable SSH access. So what we want to do is ensure all network devices have SSH enabled and are accessible from the Ansible control node. And we want to do this because Ansible uses SSH for connecting to and managing Unix-based systems. Secure, consistent access is essential for automation. So, and then once we're yep, so the parent of this task is our epic, and then once we're done with that, we'll move to the successor here. So see how easy that is. Really not a problem to do things right. Okay, so yeah, so let's do that. Let's enable SSH access for all of the devices here, and then make sure that we can connect to them from the automation server. Okay. Man, and I really don't know how to do that. Well, let's have some conversations with the perfect. Yes, that's great. Perfect. Yes, that's great. Now I will work on the first work item, enabling SSH. In the real world, how could I go about accomplishing this task?
Enabling SSH on network devices is a fundamental step to facilitate secure remote management and automation. The process may vary depending on the type of network device and its operating system. Below are the general steps for enabling SSH on Cisco Nexus devices and Cumulus Linux devices as per your network inventory. Cisco Nexus devices. Access the device. Access the device through the console port or any other available management interface. Enter configuration mode. Enter into global configuration mode using the command. Copy code conti configure host name and domain name. Configure a host name and domain name for the device.
No, but I'm not talking about that. So no, I'm not talking about the configuration. I'm talking about the practical, physical, and managerial aspects of this in the real world. I mean, like, you're telling me that I just need to log into the devices. Well, what if the devices are not powered on? How can I turn them on? And if you just say flip the switch, well, that presupposes that the devices have power. How do the devices get power? Where do I plug them into? Where do the devices stay? Do they stay on Jim's desk buzzing at him incessantly throughout the day? How do I actually go through this for the things that actually matter in the real world and not just things device centric that can be easily looked up in some manual somewhere?
Absolutely. The practical, physical, and managerial aspects are crucial.
Yeah.
Let's discuss these elements. 1. Location and rack mounting. What? Network devices should be securely mounted in dedicated equipment racks in a climate-controlled environment like a data center or a server room.
Exactly.
Why? This prevents unauthorized access, reduces risk of damage, and ensures optimal operating conditions.
Yes.
2. Powering devices. What? Ensure that devices are connected to a stable power source, ideally through a UPS, an interruptible power supply, to guard against power fluctuations and outages. Why? Stable power is critical to prevent device malfunction and downtime.
Thank you.
3. Cabling and connectivity. What? Properly cable the devices, ensuring network connectivity. Use cable management to avoid disarray.
Yeah.
Why? Organized cabling reduces the risk of disconnections and facilitates troubleshooting.
This is so good.
4. Accessing devices. What? If devices are powered off, physically access the server room or data center to power them on. You may need security clearance or escort depending on company policies. Why? Physical access may be necessary for initial setup or in case remote access is unavailable. 5. Console access. What? Have a console server or a KVM, keyboard, video, mouse, switch available for initial configuration if the devices don't have IP addresses assigned or SSH configured.
Right.
Why? Console access provides a direct way to interact with the device, bypassing network
so
connectivity.
we can do that. We can
6.
do that.
Inventory and documentation. What? Maintain an inventory of devices, their locations, IP addresses.
Okay, so let's do that. So what we're gonna do is we're gonna presuppose that let's see here, 1, 2, 3, 4 precursor steps are complete. Now, if you were in the real world, you would need to have you can't just assume everything is set up and ready to go. Typically they will be, but especially when it comes to things like a UPS supply, things might seem like they're set up and ready to go, but we have the UPS supply, but it's in a cardboard box. It's like somebody didn't plug in the UPS supply, and now we're sitting ducks if we have a power fluctuation. This is important. So we're gonna assume that the network devices are securely mounted in a dedicated equipment rack in a climate controlled environment, like a server room. So let's look at our lab. Let's think about that while looking at the lab. So here's the lab. We have a data center. So we're going to assume that this is a data center with all of the rack mounting, layer 1 stuff, climate controlled environment, secure access. It prevents unauthorized access, risk of damage, optimal operating conditions. We're going to assume that the devices are connected to a stable power source, ideally through a UPS. They have stable power. We're going to assume that it's all cabled up correctly, which we did spend a lot of time on. So that should be fine. And then, it's virtualized, so we don't need to worry about actually organizing the cables. But in the real world, that's another thing you need to assume. And this is where, like, you can be a superhero if you, like, have some other hobbies. Like, for example, 3D printing. From what I understand, there's, like, some really solid 3D printers. And, like, you can do printer network cable. Yeah, so like you could print out like a just a really simple, cheap, basic things that are like you can even see it right here. Like, see how there's like really simple cable management things. So you can be like kind of a superhero just by like having a basic 3D printer and just like on your own time, like printing out something. It's kind of overkill in a lot of cases, and don't let it delay the project. But, you can imagine how something like this could be pretty useful for cable management, something like this. So, like, there's always a chance to go above and beyond, and I invite people to do that. Of course, you got to be careful to not be stupid. Like, let's say your materials that you're using would like melt all over you try to put it by a fan or something that has hot air, and it just melts all over everything. So you don't know what you don't know. So try as you might not to be stupid. You might end up being stupid. So sticking to the plan is never a bad thing. Attempting to go above and beyond only to prove how little you know is a bad thing. Okay, so we've got the cable and connectivity. We don't need to worry about that. Accessing devices. So if the devices are powered off, physically access the data room. So this is where we're at. We basically got to pretend here that we're like on in the building on the site, and we need to walk up to each of these gears. So this is going to be our data center, like on the basement or whatever of the site. Probably the basement, because warm air rises, you want to keep it cool. So yeah, it's going to be like in the basement of the building. We'd have to walk down there and make sure everything's physically set up the way it is. All these prereqs that we talked about, the location and rack mounting, the power for the devices, the cabling connectivity, and then the ability to access them physically, either through some sort of security system, some sort of like escort system where you can't access it on your own without someone else being there. Some kind of security, because once they have physical access to the gear, there's really no limit in what people can do. So you really need a security program. And there's a really good example of this, Aaron Schwartz. So if anyone's not familiar with this character, this is the guy who made Reddit. And this is really a sad story in tech, because he is an absolute unequivocal genius. And he was going to do really awesome things for the internet, but he actually committed suicide, because he was he's a person of color, and he was trying to be made an example of under the Computer Fraud and Abuse Act. He was painted out to be like a dangerous computer hacker, and taken to court for it, and he buckled under the pressure. He just couldn't deal with being talked about in such a bad light, because he is this child kind of privileged guy from a very wealthy, successful family that probably can't handle people treating him poorly very well, because he probably hasn't been treated poorly all that well throughout his life. I don't know. I'm just making things up. I'm not trying to trivialize this situation or speak anything to anyone's character. This is a really tragic story. I encourage anyone to go and familiarize yourself with it, because this is a very important person when it comes to the history of the internet. Uh, and specifically when it relates to this this accessing the device, this physical security, because the reason he got in big trouble is because he was a professor of the school. Yeah, I think it was Harvard. Yeah, so he was a research fellow at Harvard University's Safra Research Lab. So as such, he made a fair assumption, in my opinion, that he had authorized access to, a server room. So like that he was just able to access, the data center or whatever, because it's his job. Like, this is just the stuff he does every day is work on stuff related to this gear. So like, he plugged into one of these devices and he did what he needed to do his job. And that was interpreted as unauthorized access. That was interpreted as just basically a person off the street stealing data. And in my opinion, that's an example of bad security policies, because if he truly didn't have access to that room, there should be these policies in place that make that very clear to him. And then, if he did have access to that room, this shouldn't be the controversy it was. So I'm trying to get this like really straight, because again, this is such a tragic story. I would hate to get anything wrong or say something needlessly controversial, or in other way not do this the diligence it is due. But I do believe that this is kind of a cautionary tale when it comes to security policies, and a lot of this could have been prevented if there were better security policies that were more clearly defined and enforced in better ways. And like, honestly, for me, it's like not just security policies. It's like, if this is his job and if he's working for this institute and he's doing his work, like, just because the work is like cutting edge and controversial, in my personal opinion, he would have absolutely walked away from this court case completely unscathed. He would have absolutely won it. And like, I think he did have to go to like jail for a few days. Yeah, so like, let's see here. And I'm a little bit off topic. Yeah, so he was arrested by the police for breaking and entering charges. And this is where this is what I mean when it comes, because this was I believe with so what he did is he connected to a computer in the MIT network in an unmarked and unlocked closet, setting it to download academic journal articles systematically from JSTOR using a guest user account issued to him by MIT. So like, in my opinion, okay, well, he's a employee of this is his job, is to do that. And I think that's what he thought as well, and I think that was fair to think. But MIT, didn't agree with that. So it's like, already you have this juxtaposition where you're like hiring someone to do their research job as part, and so they do what they need to do their research, and then you arrest them for doing their job. So already there, you need more clearer job duties. But really, in my opinion, the main problem is, this computer to the MIT network was in an unmarked and unlocked closet. Like, no, that's not okay. If it's a critical device, that's in a server room or a data center, and this unmarked closet, that's a server room. If you've got this critical gear in there, that's a server room. You have to lock that down. You need some sort of policy where you have to request security clearance to it. You need some sort of policy where you can't access it alone. You have to have an escort there with you. So this is not trivial stuff. This is how people live. This is how people die. This is how people do groundbreaking humanitarian discoveries and research that benefit all of humanity. And if you don't have these clear policies, this is how you get these, these gray areas where it's like, okay, yeah, maybe he wasn't being a choir boy when he was systematically downloading articles from JSTOR, but at the same time, if that's what he's got to do what he's got to do, then he should have authorization to do that in some official way. And we're talking about a work environment where they didn't even lock and mark with some sort of keep away or like no trespassing sign on their critical network infrastructure. So like you can see how this is just set up to be a really contentious situation. It's just like a trap waiting for anyone to fall into. If it wasn't him, it might have been another researcher that came a year later or whatever. So yeah, really tragic, sad story. Trying not to I'm trying to do it justice in what I'm talking about here, but yeah, this is a cautionary tale. Please go and read about this. There's even some like entertaining documentaries, like really easy to watch documentaries. Yeah, so like this is a very historically relevant person when it comes to the internet, and I'm not really willing to say much more than that because this channel is just about computer literacy. It's not an opinion channel or political channel or anything like that. So that's all I'll say about that, is that accessing devices is a big deal. Security is not something to take trivially or lightly, because security can be a matter of life and death. You can get a situation where your security was not thought out well enough and somebody did something that they thought they could do. Nope, it turns out they can't, but it was hard for them to know that because they were just doing what they thought was required for the job. And now you've got this giant court case. You've got people at each other's throats, and tragically, you've got someone that just can't handle that pressure and ends up killing themselves. And this is a really unique person with skills that just can't be replaced so easily. So you can prevent all that just by locking your server room. Oh, I know. It's I don't know if it's it seems like a very tricky thing to do, or putting a sign that says no access without it seems rough. I know it seems hard. All right, so what we're going to do for my lab is we're going to assume that we do have authorized access. We're not going to be getting in trouble with this company. So we are the authorized, network admin for this campus. We're like the head honcho. We're like the CTO. We can do whatever we want on this network. So we're going to assume we're like a man, or like, a person, whoever the heck we want to be, or like we're some magical, like talking animal, talking dog. And for some reason we speak English, and not like, yeah. So we're a talking dog that speaks English, and we're gonna take we're gonna go from room to room in this campus, and we're going to by way of council access to the devices, set up the bare minimum we need to accomplish this first task here in our epic, which is to enable SSH access. So we need to set up a management network through which we can access SSH. Okay, so and let me ask the AI about this. Okay, so help me think about, develop, architect, and design a management network for this network that I have that we built the host.ini file for.
Designing a management network is crucial for securely managing and monitoring your network infrastructure. A well-designed management network isolates management traffic from general traffic, reducing security risks. Here's a strategy to help you architect and design a management network for your campus network. 1. Isolation. What? Isolate the management network from the production network using a dedicated VLAN or subnet. Why? This ensures that management traffic is segregated, reducing security risks and potential impact on production traffic. 2. Dedicated interfaces. What? Utilize dedicated management interfaces on the network devices for connecting to the management network. Why? Separating management traffic at the interface level provides an additional layer of security and isolation. 3. Secure access. What? Enable secure access protocols such as SSH for device management and HTTPS for web-based interfaces. Why? Secure protocols encrypt management traffic, protecting it from eavesdropping and unauthorized access. 4. VPN access. What? Implement VPN access for remote administrators to securely access the management network. Why? VPN provides a secure tunnel over the internet for remote management, ensuring data confidentiality and integrity. 5. Firewall protection. What? Place a firewall between the management network and other networks to control access and protect against attacks.
Okay, so that's fine. We've already got our tasks. We don't need to just make new tasks. So here we go. Here's an example architecture. So yeah, so the first thing we do need is a dedicated subnet for management. And then we might need VLANs. We might not. I'm not sure yet. You can have layer 3 all the way down to the access. You don't really need a VLAN if you do that. So there's different architectures. So we can connect the management interfaces. So first let's create a dedicated VLAN or subnet for management. So let's do that. So we'll do management subnet. So we'll make our own text box here. Oh shoot, I forget how to do that. Oh, it's this, isn't it? Yeah, okay. So management subnet. And this is documentation, so this is really essential. So let's have it be private space, of course, 10.0.0.0. And we can do a slash. You know what? Let's do it for each of these areas. Now the thing is, yeah. So we gotta know a few things. We gotta know where we want layer 3 to terminate. So we could have it terminate at the distributions, and we could have these be VLANs, or we could have it terminate at the access layer and have different subnets. So let me ask the AI. So I believe one of the things we have to determine right away with this network is where we want layer 3 to terminate. And I believe, and correct me if I'm wrong, that there are two good choices for deciding this. The first good choice is that you would have it terminate at the distribution layer, and then you would use spanning tree to block a link. But I believe that a better choice, especially in this case, would be to have the termination of layer 3 occur all the way down as low as possible at the access layer, because this would, the access layer, ACCESS layer, because this would be better for like load balancing and stuff, because then you would not have to shut down a whole link. Instead, you could use like a cost equal path. So does this make sense, or am I way off in my thinking about this?
are on the right track.
Yeah.
The decision of where to terminate layer 3 routing in a campus network architecture is crucial and affects various aspects such as load balancing, redundancy, and fault isolation.
Yep.
The two common approaches you mentioned, terminating layer 3 at the distribution layer and at the access layer, are both valid, but they serve different purposes and scenarios.
I'm going to do access.
1. Terminating layer 3 at the distribution layer. Pros. Simplicity. Easier to manage and configure, especially in smaller networks. Cost. Less expensive as layer 2, switching, is typically cheaper than layer 3, routing, at the access layer.
Really?
Spanning tree. Utilizes spanning tree protocol to prevent loops and provide redundancy. Cons. Block links. Spanning tree protocol, STP, blocks redundant links, which can be inefficient. Reconvergence. STP might have slower convergence times after a topology change, affecting network stability. Broadcast domain. Larger broadcast domains due to extended VLANs can lead to
screw this. Nope.
2. Terminating layer 3 at the access layer.
Yay.
Pros. Load balancing. Enables equal cost multipath, ECMP, routing for efficient utilization of uplinks.
Thank you, please.
Fast convergence. Faster convergence times and improved fault isolation. Smaller broadcast domains. Smaller and more contained broadcast domains, reducing unnecessary traffic. Flexibility and scalability. More flexible and scalable, especially suitable for larger or growing networks. Cons. Complexity. Increased complexity in configuration and management. Cost. Potentially higher cost due to the requirement for layer 3 capabilities at the access layer.
Yeah, I mean, that's fair.
In a modern network design, especially in data center and large campus environments, terminating layer 3 at the access layer is often preferred due to the advantages of load balancing, fast convergence, and scalability. It aligns well with the principles of spine-leaf architecture, which is common in data centers, where every device is equidistant and has multiple equal cost paths. However, the choice depends on the specific requirements, constraints, and goals of your network. Factors such as budget, existing infrastructure, administrative skill set, and future expansion plans should all be.
So is there like an RFC or something that you're drawing this information from? Can you please tell me what resources make the most sense to reference for decisions like these?
While there isn't a specific RFC that dictates where layer 3 should be terminated in a network, various best practices, design guides, and textbooks offer insights and recommendations on this topic. Here are some resources that can be referenced for making decisions like these. 1. Cisco Design Zone. Resource. Cisco Design Zone for campus description. Cisco provides comprehensive design guides for campus networks, including recommendations on layer 3 termination, routing protocols, and other design considerations. 2. Books. Title. Top-down network design by Priscilla Oppenheimer. Description. This book offers a methodology for network design and covers various aspects, including layer 3 termination and hierarchical design. 3. Vendor documentation. Resource. Vendor-specific documentation, e.g. Cisco, Juniper, Arista. Description. Network equipment vendors provide detailed documentation, white papers, and design guides on network architecture and best practices. 4. Online forums and communities. Resource. Network Engineering Stack Exchange, Cisco Community, Juniper Forums. Description. Online communities are valuable resources for discussing network design considerations and learning from the experiences of other network professionals. 5. Industry conferences and workshops. Resource. Conferences such as Cisco Live, NANOG, and workshops by industry organizations. Description. These events often feature presentations, workshops, and discussions on network design and architecture. 6.
Alright, so yeah, that looks good to me. Isn't this cool? Like, this is so cool. Yeah, so that looks good to me. Yeah, the task we're trying to do is configure SSH, and we can imagine that. Okay, you know what? So we made our first key decision. So let's update the ticket with that. And we're gonna say, enable SSH. So first key decision. A management network has to be architected for this to occur. A few key decisions, design decisions, will need to be made and may arise organically as the project progresses without discovered in hindsight only and not able to be thought of in advance. In advance, known key decisions and their choice will be listed here until SSH access is successfully enabled in-band network-wide. So the first one we need to make, we're going to do L3 boundary. So it's going to be design concept, L3 boundary, and then design decision, terminate at edge, and then eliminate need for L2. And there's fair decisions to make either or. Now the really cool thing is there's a really good article about this. So I think it's like network something, but L3 boundary network lessons, I think. Yeah, so they have it, this is a common thing to consider. So like Cisco has an article on this. Network lessons is the best, I would say. Yeah, so I really like network lessons. I just think it's like one of the best resources online. So L3 termination. Yeah, so here we go to design lines. This is kind of unrelated, but VLANs are locally significant. If you have trouble understanding VLANs, you're like early on in your career, you have. Oh, you know what? It's packet life. You have to read this article. Like this is the best article I've ever read on VLANs. So like, yeah, actually I think it's packet life and not network design. I think both are good, but I think the one I meant was packet life. Yeah, this is the one I meant. So what I mean is packet life. Sorry. And like notice how short the articles are. It's so good. Like I can read the whole thing. So yeah, and let me do that because we're trying to make this decision here. So hybrid access layer design revisited. A few months ago, I wrote an article explaining the benefits of a hybrid enterprise access edge design, which allows for both routed and switched traffic at the access layer. Reading over some of the comments of that post, it's clear a number of readers did not understand the motivation behind such a design. That was partly my fault, as I underestimated the need for more illustrative topology diagrams. So today I'm taking another shot at it in an effort to both convey the idea more clearly and to address concerns raised in comments in the first post. So legacy enterprise campus designs employ routed links only within the core and between the core and distribution links. So that's a legacy design already. We're definitely not going to do that. Okay, then along came multi-layer switches, which made it possible to extend layer 3 functionality down to the access layer. And you can use ECMP for here. Equal class Lewis. Okay, and then a third recently developed access edge design employs virtual switches and multi-chassis link aggregation at the distribution edge. So I think that's the one we would like to do if we can. But if we can't, we'll do the layer 3 at the edge approach. We want to stay cutting edge on here, but there's a way you can Yeah, so if you have a requirement for layer 2 access between points, you're using some really weird gear, um, which might be possible like in a hospital setting or something. Um, you can use this hybrid approach. Um, I love this answer here. If you can manage the layer 2 network and you can manage the layer 3 network, you can manage this design. If you can't manage either of the first two networks, it's time to hit the books or look for a new job. I love that answer. Or subscribe to this site. So, uh, yeah, how should VTP be? Unless you have a very good reason to use VTP, don't. Please. Hopefully, you shouldn't even know what VTP is. You should learn what programmability in Python is instead. So, yeah, I love this packet life. It's so good. It's just so good. Who is it even? Oh, it's made by Stretch. Jeremy. Oh, is this Jeremy? I feel like this is a pseudonym. Oh no, it's okay. It's not. I thought it was the same Jeremy that made. Oh, wait, maybe it is. Oh, is this seriously the guy that made Netbox? I thought his name started with a C. I will follow this guy for sure. Huh. I don't know if this is like a pen name or something, because I'm pretty sure. I'm pretty sure the guy who made Netbox his last name isn't Stretch. But obviously I'm wrong because we can see it right here. So, all right. So I just wanted to be clear about that being one of the first distinctions we need to make in our management network. So, okay. So we're gonna ask the so complete this thought uh thought write out the rest of the design concepts will need to consider and the best possible design decision we hypothetically make with no limitations. I mean, we're
Implement
not going to use
VLANs for different network segments, management, data, control, with dedicated subnets to enhance security and traffic management. Design concept. IP addressing scheme design decision. Utilize a structured and hierarchical IP addressing scheme with appropriate subnetting for scalability and efficient route summarization. Design concept. Redundancy and high availability design decision. Deploy multiple paths, HSRP, VRRP for gateway redundancy, and dual home connections to ensure network resilience and minimize single points of failure. Design concept. Access control design decision. Implement ACLs, firewall rules, and AAA, authentication, authorization, and counting for secure access to network devices and resources. Design concept. Encryption and security design decision. Utilize SSH for secure management access and employ VPNs for secure remote connections. Enable features like port security and BPDU guard. Design concept. Logging and monitoring design decision. Set up centralized logging, syslog, and SNMP for real-time monitoring and alerts. Implement NetFlow for traffic analysis. Design concept. Configuration management design decision.
I mean, we're not going to use VLANs, right? We already decided to put the layer 3 boundary at the access layer, right? So do we even need VLANs at all? Yeah.
Recorrect. The decision to terminate layer 3 at the access layer can indeed reduce the reliance on VLANs for segmenting traffic within the network. However, VLANs can still be beneficial in specific scenarios even in a network where layer 3 is terminated at the access layer. Here are a few considerations. 1. Global segmentation. Even with layer 3 at the access layer, there may still be a need to segment traffic globally within a switch for security, organizational, or application-specific reasons. VLANs can be used to achieve this. 2. Link aggregation. VLANs can be used in conjunction with technologies like Ether channel for link aggregation, which can help in utilizing bandwidth efficiently. 3. Service segmentation.
All right, so I guess I don't know. I feel like that was kind of a bad answer by the AI. So okay. All right, so let's think about the IP addressing. So I think we're gonna have to assign a subnet to each of these areas at least. So let's do let's do that. So let's assign 10.0.0 and I think we can do a /24. I kind of want to do more than that. I want to do a /16. But I mean, we do need to have room for expansion, but it's not like we're going to, I mean, we'll have 255 different, segments. We don't have 255 floors. So, yeah, 10.0.0.0 will be our core. And then this is going to be management. Okay. And then for our data center, it'll be .1. Like so. I feel like we don't need, I don't know. I feel like once we get a lot of, because we could have all kinds of servers. We could have more than, I mean, I don't know. More than 256 servers seems kind of ridiculous. Yeah, I don't know. Okay, so we're going to make this 1.2. I don't know if these are good decisions or not. All right, and then we'll make this 1.3. And then we'll make this one down here, .4. All right, so that looks good to me. We can see the power of automation. Like if you have good automation set up and you got to change all this stuff, hopefully you'll be able to do it in like an easier way. And even just like having your documentation be taken care of for you, that's pretty huge. So we're almost at the 2-hour mark. Haven't really made a ton of progress. So yeah, okay. So now we're gonna imagine that we're pushing a card or like walking over with a laptop to each of these devices and plugging into them and just configuring the basics. So let's start with this one here. All right, so we'll log into this. So we need a new password. Let's just name it admin. Okay. So now we need to configure the uplinks, of course, because we're trying to build out a whole network that we can access, anywhere on the network. We want to be able to plug in a PC and then get on there. So we'll need like a DHCP server off in our data center. We got a lot of work to do. a lot of work to do. It's kind of ridiculous. Okay, so here we go. So we do have a management connection. Yeah, so we do have a management port that we can have a out of band management network, which I would like to have. Let's do it that way. So let's have a out of band management network. Um, and then we'll have an in band management network as well. But let's start with the out of band management network. So the out of band management network will either connect to all of the management ports, or we'll custom create a out of band management network, and then the out of band management network will connect to itself as well. So at each of these like spaces, we're gonna have an out of band device, and then as long as we're and then we'll be able to connect to the out of band device and access each of these out of band. So let's ask the AI about this. Okay, so I've decided the first thing I want to do with this network is I want to create a dedicated out of band management network for it. So describe to me how I can do this. Can I do this with just simple, cheap, basic hub devices and connect each of the dedicated management ports of the switch, the out of band dedicated management ports of each device on my network into this hub, and then string all the hubs together? And then can it work this way, or is there other stuff I'm not considering and this way won't work at all?
Creating.
Yeah,
The
I want to do
dedicated
that.
OOB management network is a wise decision as it provides a separate path for
First thing I
managing your
wanna
network
do.
devices independent of the production network. This approach enhances security and ensures manageability even when there are issues with the in-band network. Here's how you can go about setting up an OOB management network.
Yep.
1. Dedicated management ports. Connect the dedicated management ports of your network devices, switches, routers, firewalls to the OOB network. These ports are specifically designed for management traffic and are isolated from the in-band network. 2. Switching infrastructure. While using simple hubs might be tempting due to cost considerations, it's better to use network switches.
It is.
Switches are more efficient than hubs, provide better performance, support VLANs, and reduce collision domains.
Yep.
Hubs broadcast traffic to all ports, potentially leading to security risks and network congestion.
Collision domains.
3. Topology. Connect all the management ports to the switches in the OOB network. You can daisy chain the switches or use a hierarchical topology, depending on the size and requirements of your network. 4. IP addressing. Assign a separate IP subnet for the OOB management network. This segregation makes it easier to apply security policies and avoids IP conflicts with the production network. 5. Router, gateway. Have a dedicated router or gateway in the OOB network to route traffic to and from the management network. This router should have strict access control lists, ACLs, and firewall rules. 6. Remote access. Set up a VPN server or a jump host within the OOB network to facilitate secure remote access for administrators. 7. Access control. Implement strong authentication, authorization, and accounting (AAA) on all devices within the OOB management network. Use secure protocols like SSH for device access. 8. Monitoring and logging. Deploy monitoring solutions and centralized logging within the OOB network to keep track of activities and device statuses. 9. Power management. Consider adding intelligent power distribution units (PDUs) or remote power switches (RPS) to the OOB network for remote power cycling of devices. 10. Backup connectivity. Have a backup connectivity option such as a cellular modem for the OOB network, ensuring access even if the primary connection fails. 11. Network segmentation. Although VLANs are used less with layer 3 to the edge within the OOB network, VLANs can be used to segment different types of management traffic if needed. Conclusion. By implementing these steps and best practices, you can establish a secure and reliable OOB management network. Using switches instead of hubs and considering the above aspects will ensure that the OOB network serves its purpose effectively and efficiently.
Okay, so all right, so yeah, this looks just good. We're gonna, yeah, so that's a fair point. Tell me more about a collision domain and why it makes more sense to use a switch than just a hub that doesn't have protections against this concept.
A collision. Domain is a network segment where data packets can collide with one another when being sent on a shared network cable. In Ethernet networks, especially those using half-duplex communication, only one device can transmit at a time. If two devices try to send a packet at the same time, a collision occurs, resulting in both packets being discarded and needing to be retransmitted after a random delay.
Yeah.
Hub. Functionality. A hub is a simple networking device that receives a packet on one port and broadcasts it to all other ports. Collision domain. Each port on a hub is part of the same collision domain. Any device connected to the hub shares this collision domain with all other devices connected to the hub. Issues. This can lead to a high number of collisions, especially in a busy network, causing reduced network efficiency and performance. Hubs operate in half-duplex mode, meaning devices cannot send and receive data simultaneously, further limiting the network speed.
I mean, a hub is just, there's no such thing as a hub. Like everything's a switch. Like if you find a hub, you got it on eBay and it was made in the 80s. So, but we're gonna drop an Ethernet switch. So this is our out of band. So we're gonna call this floor 1 OOB. Uh, floor 1 OOB. Okay. And we can put all our OOBs right here. And we'll have a dedicated OOB for each section of our network. So it'll be in the closet where all this stuff is. This core will probably be in like the same closet as one of these, or I don't know. So that's our floor 1 OOB. Now we have a data center OOB. Okay, looks good to me. Then a core OOB. Okay, and then internet OOB and a WAN OOB. Okay, and these are probably better to have them like here. Yeah. That makes a lot of sense. Okay, and now we're gonna hook up all of the management ports to our OOBs. OOBs I think already have like 16 ports on them. Oh, they only have like 8. Um, 2, 3, 4, 5, 6. You know what? That's gonna be fine. That'll be enough. So yeah. So now let's hook up everything to the OOB. So these are the management. Yeah. Yep. All right. So kind of a tedious task we've got here, but not too bad. And we're making good progress, so it's always good to make progress. All right. What a mess. What an absolute mess. I mean, that's a network for you. You want it to look nice or you want it to work? Yeah, I'm not sure what the deal is with these devices, if they have a OOB. These devices definitely do not. So I'm just picking the last port for those. It's kind of nice when the device already has a management port on it. Oh, that would have been a disaster if we were out of ports on that. All right, so yep, now we've got all our OOB devices. So the OOB devices now have to connect to each other, um, and they can use like a spanning tree. Uh, hopefully they have spanning tree. Okay, so let's sniff one of the OOB links. Uh, Hopefully we can see if it has spanning tree. If it doesn't have spanning tree, that could be a problem. We have LLDP. Uh, yeah, I don't see spanning tree, unfortunately. That could be a bit of a problem. I mean, it's just our OOB network, so like it should just sit there unused, hopefully. So we don't have to get that sophisticated with it. Um, let's just make sure not to cable it up in a loop, which is easier said than done. So we'll just cable it from here to there to there to there to here, and then we won't cable it back to there. And hopefully that will be good enough. Okay, we don't really have a lot of room for growth. Well, you know what? I think we're fine because we had another floor. We just add this to our out of band network, which is just one large thing right now. So it's kind of not the best network in the world, but as I said, it should just sit there unused for most of the time. We only need it if there's an absolute emergency. Um, but we'll have it. So okay, so now we need to go by device on the network and set them all up for connectivity. Make sure that they all have a ARP table that has everything resolved to each of the devices. Make sure they have an IP table. So our OOB management is going to be let's make our OOB. I'm tempted to have everything as a /24. I need a break. I'll be. Oh, and we're almost at the 2 hour mark. So we've got to decide about our out of band network. We need an IP addressing scheme for it. So here's, and you know what we could do as well? We could place a DHCP server on it. So I think I would like to do that actually. And I'd like all my services to come from my data center. So yeah, I think I'm gonna have a DHCP server on my network. Oops, these did not start up. Oh, and now they're frozen as well. Yeah, there's some kind of issue. All right, so there's an issue with my Nexus devices. Let's stop everything and start it again. Maybe that'll fix it. So this is kind of a not the best device to have a simple DHCP server on. Yeah, it looks like it's going to have the same problems in booting up. Let's ask the AI. Tell me why this wouldn't. Tell me why this didn't boot up, and what I can do to get this Nexus device to operate normally.
The output you posted seems to be from the UEFI, Unified Extensible Firmware Interface shell. This typically appears when there is an issue with the boot sequence or when there is no valid operating system or boot file found in the configured boot order.
Yeah.
Here's a brief breakdown of the potential issue. UEFI shell. The device has entered the UEFI shell, a pre-operating system environment that can be used to run various basic commands. Mapping table. The shell is displaying the various file systems, FS0, FS1, etc. and block devices, block 0, BLK1, etc. It has detected. These are different partitions and devices available on the system. Skip startup. NSH. The message indicates that it's attempting to run a startup script, startup. NSH, but it either doesn't exist or isn't functioning correctly. Possible solutions. Check boot order. The boot order in the UEFI BIOS settings may not be correct. Ensure that the correct device or partition is set to be booted first. Locate boot file. If you know the location of the boot file, usually ending in FE for UEFI systems, you can manually navigate to it using the UEFI shell and execute it. Startup script. If there is supposed to be a startup NSH script, ensure that it is located in the root of the file system and is correctly written to boot the system. Reinstall, recover OS. If the operating system or boot file is corrupted or missing, you may need to perform reinstallation or recovery. Hardware issues. Ensure that there are no hardware issues, such as faulty cables, connections, or hard drive failures, that might be preventing the system from booting. Consult documentation. Refer to the Nexus device's official documentation or support channels for device-specific troubleshooting steps and recovery procedures. Since this is a Nexus device, it is essential to follow Cisco-specific procedures for troubleshooting and recovery. Cisco's official documentation and support resources would be the most reliable source for resolving boot issues on a Nexus device.
Okay, I changed the...
It appears that the device is still having trouble booting. The messages indicate several issues. Syscon checksum failed. Using default values, this suggests that the system configuration is not valid or is corrupted, and the device is using default configuration values. No BIOS info found. This warning suggests that the system is unable to retrieve BIOS information, which might lead to boot issues. Failed to launch IPXE and failed to launch shell. The device is trying to launch IPXE, the network boot firmware, and FE shell but is failing to do so. No autoboot or failed autoboot. Falling to loader, the system has failed automatic booting and has fallen back to the loader prompt. Steps to troubleshoot. Check configuration. If possible, verify and correct the system configuration. The Syscon checksum failed messages indicate that there could be an issue with it. Boot manually. At the loader prompt, you might try manually loading the kernel and initiating the boot process. Check the device documentation for the specific commands needed. File system and boot files. The messages indicate attempts to read from the file system, X2FS. Ensure that the necessary boot files are present and not corrupted. Recovery mode, reinstallation. If manual booting doesn't work, consider booting into a recovery mode or using installation media to repair or reinstall the system. Consult documentation. Refer to the official Cisco Nexus documentation or support channels for device-specific recovery and troubleshooting procedures. Hardware inspection. Ensure that there are no hardware faults that could be causing the boot issues. This situation might require a more in-depth investigation, and accessing the device documentation or seeking support from Cisco might be necessary for resolution.
Alright, let's see if we can get some documentation. Yeah, okay, there we go. GNS Lab. That's funny. Oh, they want to re-import it. Oh, is that what's happening? Oh, okay. That's why. It's because I entered auto provisioning mode. Ugh. That makes sense. Okay, so this is the answer here. You have to choose the right settings upon boot up, or else it'll mess itself up. Uh, what about this boot flash? Let's try this. Flash colon. Nope. Boot flash colon, and then what do we got here? I'm confused. I am very, very, very confused right now. Oh, I see. Okay, no. Okay, so yeah, I don't get what's going on there. Yeah, it's rough. It's very tricky. Very tricky. Okay, so I mean, I feel like sometimes it's like I can only have one, two at a time or whatever. I mean, what we could do is just the cabling's going to be a nightmare, but what a disaster. So if I do hit exit, then I come to this prompt, which looks like it could be useful. So we go to the boot manager. We do have some good options here. So I would guess that you'd want to boot up to the hard disk, right? Okay. Yeah, so we've got no auto boot, and it's probably because of the auto provision mode. So for all of those Nexus devices, I think we've got to reconfigure those. I think these distribution devices are Aristas. This is probably an Arista as well. The Aristas are fine. But yeah, we gotta deal with those Nexuses. We might even need to pull them out and put them back in, which would suck. Alright, well, you know what? I think I'm going to end the video now. We're very nearly on the way. We figured out we needed some more layer 1 stuff. We need a dedicated out-of-band management network. So now we just need all the devices to boot up and put us at like a command line. And this is, you know, console access. So if we were imagining this in the real world, would be right now walking around to each of the devices after they've been set up in the the server room, and we have a security policy in place. So we're just going around. This is all greenfield, connecting in, and then the next step is we want them to all be a part of this out of band management network, and then after that we want to set up an in-band management network. So yeah, I think that's going to be the end of this video. I just need to figure out how to get these up. Let me try dropping one. So it's, yeah, this is the one that's in question, and I'll try starting that one, and then making sure that that I do not type that I do type Y. I do type Y. So pay extreme attention to typing Y. So I've got to abort auto provision, and I've got to type Y. Okay, so I am paying extreme attention right now. And then you need to set the .bin image. Alright, so I gotta pay attention. Extreme attention. Oh, was that it? There was like this little blip. I'll just hit Y right now. Why? Maybe this is it. System config checksum failed. Alright, so we gotta pay extreme attention. I'm good at that. Oh my god, we're doomed. Alright, hopefully we get Y at some point. I've got my finger on the button ready to go. These are big, beefy machines, so it takes. It's kind of like the Juniper VMX image. Oh man, this is taking forever. I just want to end the video. I've only got 4 nexuses, I think. 2 in the core, 2 as the spine, devices from my data center, and then the rest are Aristas and Arubas, I think, and then we got some Cisco's. Oh, this is taking forever, though. Man, it's just taking way too long. Okay, so now we have to say hit yes. So I hit Y and I hit enter. This is really important. Now I'm hoping Y and enter is good. Yes, it is. It said my options were Y, E, and S. But I just hit Y and enter. But it looks like that is fine. So yeah, okay. I finished that. So now we've got some more steps. Okay, so now we need to make it to switch prompt, and then we need to do this. So yeah, I think we're gonna have to do that for 4 images, and then swap out the 4 images that are in there, because we set up the wrong prop, and there's no going back. And it's not like in the real world where you can just swap it out like that. So let's do admin. Oh, it has to be at least. Oh man, this is so annoying. Okay, so it's got to be. So let's do capital P at symbol S S W O we'll do we'll do this. Let's do 1, 2, 3, 4, 5, 6. Oh, three of the. So we're gonna do A B C lowercase, A B C uppercase, and then 1, 2, 3, and then the. Oh man. See, I wish I could have gone back and hit no on that. You know what? I'll enter close the video. Maybe come back, try to figure this out between videos or something. But right now it's just a disaster, and it's gonna take too much just dead time just sitting and waiting for things to boot up. So that's it for this video. Thanks for watching, and see you in the next time.